Coming to the today's session, friends, just we are going to discuss the concepts of uh, simple linear regression with the help of some kind of the case study. Here we are going to specify that. So there is some kind of the data set with us, which is giving the information about the TV marketing and how it is going to affect the sales of the company. Okay, so as you know, this simple linear regression.
Should I give a small this thing on regression, simple regression and this one?
Yeah. We'll do one thing, Suresh. Just 10 minutes. I'll set the context, and then you can jump into the discussion, right? Okay.
Yeah.
What 10 minutes? 10 to 15 minutes. By 8 o'clock, you can start, right? Okay. Right. Now observe here, friends. So just before moving ahead to the simple regression, because you know our friend Suresh is going to talk about some simple linear regression, multiple linear regression, and what exactly the assumptions we discussed earlier, so that you can have a look on that. Because rather again revisiting by me, so just if I'm giving a chance of to one of you guys, so that you can give some kind of the insights of those aspects. Okay, right. And coming to the earlier session, which is very important concepts we have seen, that is what you call the pre-processing aspects. So and especially is a template kind of aspect. And now if I want to refer the which are all the common things we have followed, the very first thing is loading the required libraries. Okay, for this what we have used, friends, the import statement. And which are all the libraries we have imported? NumPy and as well as the pandas. This is the first step of the template. What is the second step, friends? Loading of the data set. Loading of the data set. So how do we load the data, friends? With the help of the pandas. What is the function we have used there? While loading the corresponding data, we have used some read underscore CSV. So read underscore CSV. So this thing we have used. So just based on that particular convention, you can perform the reading operation, Lakshmina. Okay, very good. And coming to the third aspect we have done. Okay, so once the data is ready, then what is the next step we have performed, friends?
Imputing the missing.
Before that, separation of dependent and independent data. Okay, separation of dependent and independent data. So for this particular purpose, what we have used, friends, because you know our data, whatever the data set I am using, so just I am using my data set and I have used my ILOC function. So if you are referencing the index based location, so that I can specify which are all the features required and which is the label required to perform the task. This is the third thing we have seen. Now the fourth one is, so once this extend by separation is over, now you need to explore. Okay, so that particular data, maybe this is missing value imputation. For this missing value imputation, so what is the statement we need to get, friends, from the sklearn library? What is the formula we have used, or what is the methodology we have used? Simple
imputer.
Very good. Okay, and to be frank, within the simple imputer, again we're having two parameters. Can someone help me?
One is fit and transform.
Missing values, and second is the strategy. Okay, now this simple imputer expects us Okay, so we need to give the missing values and as well as the next strategy. And once we come up with this missing value and strategy, next is the usage of or applicability of the simple imputer. Applicability of the simple imputer. For that case, we have used the fit and as well as the transform. So likewise, you need to explain these things, friends. Okay. So after imputing the missing values, so next thing is what we have performed, friends. Okay, encoding. Encoding again, sklearn. Within that sklearn, we are having two aspects actually. One is the compose. What is the second one, friends? We have used pre-processing. Okay. In the compose, we are having column transformer. In the pre-processing, we are having the one hot encoder. One hot encoder.
You used only once now for once the transfer column transfer, but every time we were on pre-processing one hot encoder only.
Yeah, correct. And one more thing, within this encoding, again, sklearn, we are using the pre-processing. What is the other kind of encoder we have used? Label encoder.
Label encoding.
Okay, na? So one hot encoding we are using, and at the same time we have used the label encoder also. Next, after encoding, what is the procedure we have followed? What is the next thing we have done? Train test split. Within the train test split, it comes under the category of the sklearn. And one more thing, friends, we have seen here model selection, not the data pre-processing. Model selection. Within the model selection, we are having the train test split. Can someone help me? Which are all the parameters in the train test split?
Extrain.
No. Parameters, not the outcome. Outcome
Okay,
is you are right. Yeah. Parameters.
Okay.
X comma Y comma.
Test percentage.
Yeah. Test size or train size. Finally,
Random state.
random state. Okay, na friends. Okay. Now you can say what is the outcome of this function? What is the outcome of this train test split, friends? X train. Test. Y train. Y test. Okay, these four are the options where you can observe as an outcome of this train test split. And once this is over, we have done one more thing, friends, actually latest. What is that? Feature
Standardization,
scaling. And this particular scaling also we have picked up from sklearn dot pre-processing. sklearn dot pre-processing. And we have imported what we have imported actually standard scalar. Okay, so standard scalar. So what exactly this standard scalar helps us, friends? Which are all the things we need to perform here?
It works on the independent variables.
Yeah. It works on the independent variables.
Independent variables.
You can use the fit transform of X train and fit transform of X test. Okay, na? So this is how you can refer all these 8 aspects. Okay, so one thing, friends, along with the concepts, whatever we have seen, libraries, importing, loading of the data set, separation of the data set into the independent and dependent, missing value imputation, usage of the simple imputer, and as well as the encoding technique. train, test, split, and scaling. So you should follow this kind of thing also, where we are getting the libraries from the import, which are all the libraries we are using, NumPy and Pandas. Loading of the data set, what is the basis? Pandas is the basis. And from that particular Pandas, we are getting the read underscore CSV. Next, separation of the dependent and independent. How we are going to separate? Just we are using the ILOC. Whereas in the current discussion of the simple linear regression, I may use another format so as to separate the independent and as well as the dependent variables. And thereafter, once we are happy with our dependent and independent variable separation, then it comes to the process of the data curation. Maybe that is the data pre-processing. And the first method we have used in this case is the missing value imputing, and the base for the missing value imputing is the sklearn, and we are having the simple imputer. And the simple imputer expects the parameters as missing value and as well as the strategy. That thing we have seen. And next important thing is usage and applicability of the simple imputer. First we need to fit, and then only we are able to transform that particular thing. Okay, so just we are giving the corresponding null values in the missing value specification of the parameter, and the strategy we have followed here is the mean value. And once that is over, then we are making use of this encoding actually. So encoding, you know, which is something like the sklearn orientation basically, which is initially having the compose so as to get the column transformer. And second important thing is which is making use of the pre-processing. Okay, so we can depute the one hot encoder here. And another thing is on the same grounds of the encoding technique, we were using this particular label encoder, which is a part of the pre-processing and which is again belongs to the sklearn category. So that thing we have seen. And next important thing is once we have done with our loading the data and as well as the separation of the X and Y and making use of the convention, you know, like missing values and encoding, it is a time to separate X train, X test and Y train and Y test. Many at times we have seen what is the significance of these separation. And for this particular purpose, we are using the train test split, which is a part of the model selection and which is again front-ended by our sklearn. Okay, and the outcomes, friends, obviously just we are we are inputting the values like independent and as well as the dependent values, test size, probably this is 0.25 or 0.2, and random state. At times, you know, if I want to make use of the conventions like so the random state, if you are keeping same, then though I am using multiple algorithms, the same kind of the environment would be used for all the cases. And outcome, obviously, we are getting X train, X test, and as well as the Y train and Y test. And once that is over, then we are making use of this scaling factor, friends, which is pre-processing, and there we are provided with a standard scaler, which is definitely belongs to the pre-processing step, and which gives the sklearn kind of the orientation. From that we have taken this pre-processing aspect, and once we are comfortable with our standardization, and just you can specify the standard logic on top of X train and as well as the X test. Okay, and now here I'm stopping, guys, because you know, so just what I'm doing is while explaining the things, maybe you are a software engineer or a data scientist or machine learning engineer, every time if you are having the concept, okay, or else if you are having the implementation background, or if you are having the coding I mean coding efficiency, so obviously you will be giving the explanation in a proper way. So while conducting the interviews also, friends, within 5 to 10 minutes, we can able to grasp that whether that particular person is fit to the position or not. Because, you know, the important point is the explanation comes whenever you are having the practical usage, or if you are using, or if you are implementing that particular thing, then the way of explanation is definitely distinct. Okay, now yeah, kudos Suresh, and good start actually. Like, you know, in all these remaining 14 sessions, what I am doing is just to maybe the members can voluntarily give the 10 minutes talk, which is really helps you if any problems, or if any pitfalls are there, so that we can help together. Like, you know, so
No,
like
actually,
some.
Uma, here I have not crossed your limits. What you were telling till now, I was into that only. I didn't add
Exactly.
anything more.
Exactly. That is enough. That is enough.
This
And
is what you have told till now. The
ah,
same thing I have put in my words and I have
because the
only the
problem.
additional that equations I have put over.
Exactly, friend. The problem here is many blogs are there, many sites are there, and what they're doing is they're unnecessarily giving some nonsense data, and
Yeah,
obviously
it's
the
really getting
learners
confused in many places.
confused.
Everybody is giving each and every definition,
Many
different
aspects.
definitions.
Yeah, that is not authenticated actually. So that friends, maybe we are having YouTube channels and websites. Many are there, but we cannot say they are authentic. Like the proper learning, and this thing should come from a proper guide, or who is really involving in the projects, or a mentor kind of thing. Okay, that's how still the digital technologies or digital transformations are getting succeeded. Okay, so the major impact is the live sessions always create some kind of the knowledge transfer to the learners. Okay, that is the most important thing. And don't feel that suppose you, at the moment you are surfing with data science or machine learning concepts, maybe you are knowing only one topic and they talk about 99 topics. That is their intention actually. And at the end of that particular website you will be having, okay, we'll give some kind of the discount, so just you can click on this so that you get pre-recorded sessions, or else you will be getting some kind of the material, all these kind of things. Don't go into the trap, friends, because if you go to any website, out of those particular 10 topics, if you are knowing 6 to 7, then you are not definitely going to get or buy that particular product. So what they need to prove, actually they need to prove that out of this 10 you know only one. So as to stand in front of other data scientists, you should know the remaining 9 also, so that they provoke you, and they initially drag your confidence, and then they play with you. Okay, don't go into the trap and all the things, friends. Okay, my humble suggestion would be, like, observe the authentic sites, like IBM or Infosys or TCS. And in case of PySpark and Hadoop, Databricks is excellent, Apache. Okay, all these things, they talk what exactly the thing is. And moreover, data science itself is a complex kind of thing. Why simply again you go and make the things complex? Don't worry about that. Okay, so with the stipulated algorithms, with the concepts which we are teaching, but our course is designed in such a way that starting from 2 to 5 years up to 15 years experience you can handle, friends, even up to 20 years also, because we are dealing the aspects in such a way. Okay, so we are covering all that, all maybe the NLP or TensorFlow kind of thing, Keras, and obviously the artificial intelligence kind of the concepts. Okay, so definitely if the people even in machine learning and data science, they may not go into NLP or TensorFlow, because just they are booming up actually. So because still they are trying to simplify the methodology of this scalar. So the people settled with scalar very nicely, and still their intention is to reduce the coding again in a one more step. Okay, that's all, friends. Okay, now appreciate Suresh. Just I am appreciating you, Suresh. Very good attempt. And that is what you need to precise and concise. It doesn't mean that taking one topic and talking entire day is not the talent, friends. And covering within 1 hour the maximum aspects we have to cover, that too with the complete satisfaction of the learners. Okay, so that is the intention. And one more thing is, will hardly check you 30 minutes of the time, and there is a clause. If I am selecting any guy, then I have to test at least 30 minutes, and within this 30 minutes 5 minutes will be dedicated to your explanation and your thing, and remaining things, so within the 20 minutes of the time, because last 5 minutes will give a chance to the candidate. Okay, like any questions you're having, or what is your expectation. Okay, all these kind of things. Okay, so within the 20 minutes you have to showcase your talents, friends. Okay, so that is what I'm saying. So stick to your basics, and don't travel ahead and don't explain more and more. More and more, if you are explaining, they will ask more and more questions. No doubt about that. Only the thing is just you stick to your question.
Like
And,
me now.
no, that is required, Suresh. But whenever you join, after joining, definitely you kind of people are real asset to the team. But simply why I'm saying this point is simply we are giving more information. They may feel bored also.
Actually, it is my strategy, Uma. What I've developed is I just want to the interviewer to my area where I'm very strong, and I'll give a small hints of that, and he'll enter into, when he enters into my area, I can blast him like anything. That's what my strategy
correct.
is.
Yeah, your strategy is correct until
That
you
is the
get,
reason why I talk more into my area.
until you get you kind of interviewer. Suppose if interviewer also your type, then the end point you can easily observe, Suresh is a miserable kind of thing, and it never ends actually. And the perfect combination I can say, like Venkat and Suresh, maybe in either way. Maybe Suresh can be the interviewer and Venkat can be the attendee, or Venkat may be the interviewer and Suresh may be the attendee, like that. Okay, so that's what you maintain the balance, friend. That's what I'm saying, because again I am repeating, your conceptual understanding, explanation, coding capabilities, all these things are having some percentage. Okay, so if you are not commanding at coding, no problem, just you can manage with that's what I have mentioned. Okay, so at least you can connect the dots. Encoding, if they are asking which are all the methods we are using, okay, sklearn I use, and within that I can use compose and pre-processing, again column transfer, and as well as the one hot encoder. So that definitely if you are practicing like this, definitely while implementing the code also you can easily implement the aspects. Okay, that is the reason why we are talking these things. Okay, now coming to the point actually. So like, if you are referencing the simple linear regression. Okay, so the main aspect here is, friends, what exactly the simple linear regression is. It is a simple narration, like I'm having one independent variable with me, and I want to check how it is going to influence the dependent variable. That's all. And so comparatively related to this x value, how my x value is generating. So that is, I want to observe the relativity between x and y. So there is a standard formula for this, friends. If you observe, y is equal to beta naught plus beta 1 x1. Okay, so as I am talking about the simple linear regression, it is enough to establish a kind of the communication between x1 and as well as the y. Okay, so now what about this beta naught? Is a constant kind of thing, friends. And this particular beta 1, can someone help me? What is this? Coefficient. Okay, now our intention is, okay, so here as a part of this particular implementation, we are having already some kind of the data set, and we are going to establish a kind of the relationship. Now one important point here, friends, there is a regression line actually, I can say. This particular regression line says that your model, okay, how the appropriate values are surrounded by your model. Generally, friends, if I'm talking about the model, what is my y in terms of y? How can I relate my model in terms of y bread or y test? Y bread or y test model in terms of model? Friends, you are jittering me. Oh my god. See, y test is your real data, original data. Okay, don't you have to remember these things very clearly, friends. Okay, the data
It's
scientist
a
and all.
byproduct.
Oh, okay, right. If you are referencing the model, this is a y predict. Predictions means what? We are predicting something, and this y test already, from the train test split, we generated this y test, y train, okay, x test, and as well as the x train. Don't miss this particular important point, friends. Okay, so it is mandatory to observe the connect between those things. So if I am saying my model and my model is generating the y prediction, and as our friend referenced, okay, revisited these particular measures, so the measuring between y pred and as well as the y test, measuring between y pred and y test. Now based on the situation, friends, sometimes I can go with the root mean square error, okay, and sometimes I can use the r square, I may use the adjusted r square, like that. Okay, based on the use case or based on the case study, I can able to observe the appropriate implementation. Now let me explain this particular aspect, friends. So okay, whatever we are having in the discussion, so far we have seen this particular data pre-processing. Now we want to see the case study related to simple linear regression. Okay, have a look on this, and some of the aspects you already we have encountered, okay, in the data pre-processing. Now if you observe here, friends, the scenario is like this. The scenario is, friends, actually I'm having the TV marketing sales information as a data set, and that particular data set is containing the information of the TV marketing I have spent and the corresponding sales. Okay, whichever the sales I am having. Now this is the whichever the data I'm having, just I am exploring the data, which is nothing but the exploratory data analysis. And here in case of the info, actually two concepts are there, friends. One is the info, second is the describe. Your describe gives that what is the maximum value, minimum value, and count, summation, all these things. But our info tells that how many null values are there, and how many total number of records, or all those kind of things you can observe. Now you see here, friends, okay, just we are having total two columns. The first column is TV marketing. We have spent how much amount we have spent, and the sales, raise of the sales, these things. And another important thing is this is containing some 200 records. Okay, my data set is containing the 200 records in case of TV and as well as the sales. Now, what this refers, friends? Can someone help me to understand this thing? What is that referring?
That records contain not null values. All the values are, there's no null values in that.
There is no null values in that. Okay, so, and if that is the case, do we need to apply missing value imputing, friends?
No, not required.
Not required. So that is what, see, concepts would be there, many concepts would be there, like so missing value imputing, or else encoding, scaling. Whenever there is a requirement, then only we are going to apply those kind of the aspects. As far as you consider this particular data set, we are not having any null value, so that we are happy with the data. You need not worry about the missing values, or you need not worry about the imputing the missing values. Okay, now it is giving some how much memory occupied, like that. Okay, now there is a twist here. So why we are getting this particular shape is observe here, friends. I am using only two columns, and you fairly observe that this is what is your y value and what is your x value here. What is your x value and what is your y value?
Your sales is a Y value.
Sales is the y value. Your TV marketing is the x value.
X value.
Now you observe here, friend. There is one criteria, like if I am making use of this particular advertising, because I'm storing this thing. At the moment I am making use of this thing, it is a combination of the rows and as well as the columns. So I'm having 200 rows and I'm having only 2 columns. Okay, shape gives that. Okay, whatever the data frame or whatever the thing we are having as a construct, and that particular construct clearly specifies that how many rows we are having and how many columns we are having. Okay, up to this it is okay. I'll come back, friends. I will come back to explain. Just I'm walking through this example, okay, so that you can feel the overall in and out. Okay, because we need to have the complete stoppage at the starting point. Okay, so we are going in this way. Again, I'll thoroughly explain this particular aspect. Okay, now can someone help me? What is the difference between info and as well as the describe? info and as well as the describe. We use it to, yeah.
Gives some info gives details about the data, while as describe it performs the basic functions and like the statistical computations, and it gives.
Today your voice is shaking, Venkat. Akhanda, you have seen or what? Okay, be careful.
No films. I have to show the movie, tomorrow. So.
Oh, you are preparing for the tomorrow's movie from now onwards. No problem, Venkat. No problem. See, the problem here is if you worry much, and that reflects in your performance also. There is a linear relationship and linear regression between your worry and as well as the performance. More worry, less performance. Less worry, more performance. Okay. Okay. Na? So just to see how Suresh, you follow Suresh in this way. Because if he's talking and if he's explaining something, his body language, his curiosity, his way of explanation, same, no difference. Okay, that you can take, and I strongly believe you're having that confidence. No doubt.
Yeah, there are a lot of things running like so.
No, friends. Actually, why yeah, no problem. You can.
It does so many statistical functions and it gives information.
Yeah, why I'm insisting is, if the interviewer feels that whether this guy has seen any Jupyter notebook in his life of his experience and all, maybe that kind of doubt if he's having, definitely he asks these kind of the questions only. Because see, maybe if you are seeing these things as a simple aspect, but in the interview point of time, every question is important. Na? You have to prove yourself within the 20 minutes. And we cannot guide the interviewer. You should not ask about info or describe. I have not prepared. You cannot say that. Even he can ask anything, like whatever the aspects relevant to our machine learning or data science kind of the aspect. Okay. One simple thing. Info gives the information about the number of records and as well as the number of columns, along with the information of whether any missing values are there or not. For what purpose we can use the info, friends, from this standpoint of view?
You can see how many columns and rows are there, how much OP that data combination is.
On thing related aspects.
Provide the list of
Columns data also, and moreover, friends, most importantly, do I need to conduct any missing value imputation or not? You can decide here only. Okay, you can decide here only, so that not nulls are there, so you need not go and play with that missing value impedance. That is the first point. Now if you see this describe, yeah, perfectly agreed, like which is giving some statistical information about the data frame, that is fine. But what is the main important outcome or main important observation of any data scientist here? What is our describe says?
It gives mean and
mainly see the identification of the distribution, and you can say how much data is in 25% and how much amount of the data is the percentage wise also. And moreover, what is the minimum value, maximum value? It gives some complete clarity about the spread of the data, friends, describing the data. So, and at this moment, okay, you can observe. Now we are entering into another aspect. Actually, if you are referencing our visualization libraries, there are two libraries most frequently used. One is the Matplotlib and second is Seaborn. Okay, so in this Seaborn, what we have done is just we try to exploit the relationship between our TV marketing and as well as the sales information. Okay, so is there any what exactly this thing is explaining to us or describing us, friends? Can you make some description out of this particular graph? Not
This
possible.
is something showing like at each value of x, how y value is changing at every point.
What is that?
The value, the x value to the y value,
Hmm.
like TV to sales,
Hmm.
each value of x, when you're considering how the y values are changing at every point, multiple values of x also,
can
the
say-
y values changing.
We can say the
Increase in the sales.
density of
Density is nothing but the how many values of x, the x values, what you're giving it.
That means whether there is any reflection is there on the marketing, on the sales or not. That is what I'm asking, friends. If TV marketing is increasing, whether we can say our sales are increasing or not.
yes, yes.
Yes, na? Okay. That means, and one more point, as some of our friends revealed that there is a density like some from 100 to 300, majority of the points are revolving around, and that too, if you see this particular area, okay, that means 150 to before 260 or 270, you could able to observe some kind of the clustering kind of aspect, if you see. So overall, friends, starting from this point, we are getting some curve like this. That means if I'm referencing this particular diagram in such a way that there is a increase of, okay, there is a increase of sales. Okay, so just there is a increase of the sales according to the TV marketing. So if I'm increasing my marketing or else some kind of the advertisements, automatically I'm getting some kind of the sales rise. Okay, and fortunately the maximum sales, okay, also category of this particular marketing. So maximum marketing spend automatically reflecting the kind of relationship. See, friends, up to now, have you applied any algorithm? Have we?
No,
We have not applied any algorithm so far, friends. Only we are exploring the data. Exploratory data analysis, nothing but we have used our info, we have used our describe, and we have used our visualization kind of thing. Then we are commenting something. So this is what, equipping your understanding throughout the data. So whatever the data set, and you need not worry about what is the value and how we are making use of the change of values. No, you need not talk about. Only our intention is we need to observe the point like that, so just if you are referencing these examples like information or else description, all these kind of thing, it is trying to give some information about the data, and it is trying to give some kind of the knowledge about the data. Okay, you need not worry about what is the value and what is the number. Don't worry about that. Only the thing is you try to get the insight of that particular data. At the same time, with a simple liner, friends, I will explain the code. Okay, definitely we'll go back and explain, but I'm seeing the flow of the algorithm, how we are following. So up to now, okay, we have done our importing the libraries, reading of the data, and as well as the processing of the appropriate records, maybe 5 records if I want from the top, and from the bottom just I can make use of the head and tail. And thereafter we perform some kind of the info to observe which are all the, whether our data is containing null or something like that. And thereafter we have seen this description also, and then we try to get some more insights of the data. Okay, always we are not interested to see the numbers, we always love to see the images. So in that particular standpoint, just we have applied the aspects of this plot. Okay, now we can able to see that yes, there is a relativity between TV marketing. If I'm increasing the units of the TV marketing, automatically I can see the reflection of the sales related to that point. Okay, now just this is the most important thing, friends. Why I'm saying important is up to now simply you can walk through and you can enjoy your data exploratory kind of thing up to that visualization. Now to learn any algorithm, that's what I'm saying. Now you can easily connect the dots. What is the stat behind this linear regression? Okay, so let me take this particular thing. Let me explain what exactly our understanding related to the simple linear regression. Can someone help me? What is the statistical model we need to bank on in the study of the simple linear regression? One minute, friends. Print screen is better because it is not allowing us. Because this is where you need to observe what is the how we are making use of this particular statistical analysis into our algorithm. And in fact, why I am spending this much time in the first algorithm is, you know, almost all the same kind of the conventions works with our other algorithms also. Okay, that is only the intention. Now, okay, let me share this. Yeah. Now you see here, friends. Just as per our analogy, you know, so there is the equation actually y equal to this constant plus the standard equation will follow. If any regression is coming into your mind, then you recollect like this: m1 x1, m2 x2, and so on mn xn. Maybe some people use beta naught, beta 1, beta whatever the means, friends. Okay, and now observe here. So far, if you are not getting what exactly y and x, it is perfectly all right. But from now onwards, you should be able to observe what exactly the each aspect or each component in this particular equation. Now, y is obviously, friends, response variable. Okay, so and we use it to say that particular thing as a dependent or target or response. Now, if you compare your statistical skills and as well as the machine learning skills, statistician says that this is a response variable. And as a machine learning engineer, you can take a chance of saying that as a target variable or label or dependent data. Nothing wrong, friends. And if you want to impress your statistician who is in your project, then you can use the word response. That is all your wish. Okay. Now C is the intercept. Okay. Sometimes, you know, what is the starting point and what is the concept, where we are starting. Okay. That is a constant kind of thing. Okay. Which is the intercept. And as mentioned earlier, you know, your beta 1, beta 2 are nothing but the coefficients. Okay. So beta 1 is the coefficient of the first feature. Beta 2 is the coefficient of the second feature, like that. But as I am talking about the simple linear regression, what is my equation, friends? Y is equal to C plus M1 X1. Okay. Now, if you observe your Y value and C plus M1 into what is our X1 value, friends? TV marketing. That's what we are trying to use here. So that means this Y is nothing but the sales. This is we are getting from our data set, and we need to compute this particular coefficient and as well as the M1 value. Now you observe here, friends. The standpoint is like this. I want to compute my Y1 and I'm having my constant value and as well as the coefficient. Now, can I expect, okay, any new value? Okay, can I give any new value? So rather than giving the existing data points, if I'm substituting my new value instead of this TV marketing, can I get the sales, friends? Whatever the predicted sales? Observe here, friends. Already I'm having the data set. And I computed my C value and as well as the M1 value. Now, my question is, out of this particular data set, maybe my data set is containing some 200 values. I'm giving new value, 201 value. Can I expect the appropriate sales with the by substituting these values, friends? Can I?
Yes, yes.
That is what you call your model. Nothing else, friend. Don't get yes, Lakshmi, very good. So that means your model is implemented in such a way that it is not only for the understanding of your existing data, and it is not only for understanding your existing sales or existing TV marketing, apart from that, our intention is, if any new value is there, if I am giving some new unseen data, then from that particular unseen data also I could able to generate my sales values. Now, one more important thing I want to clarify here. What is the difference between Y test and Y predict? We know many a times. Now, here I am saying this particular X new value, and I am comparing Y1 new value. Okay, in the model standpoint of, in the model, okay, in the context of the model, how do you differentiate these two aspects, friends? Maybe too early I am asking this question, but let me see what is your thought process in this particular scenario. Again, I am repeating the question. I have implemented my model and I have done the
Y new value will be a test value, not test exactly. Yeah, like, training and test. When you see, I can go with the new value as a test value model.
okay, model implemented, friends. Second thing is, we have tested that model also with the Vipred. Okay, this scenario you keep in mind. Now you tell me, Suresh. Yeah.
I can take it as a test for a testing purpose. Like when you split it into 75-25, I can use it as a 25%.
Which one? This one?
New value. That I'll go with the new value. I can take it as a test value now.
That is what, to avoid that confusion, why I am talking this point is, friends, you observe already we have computed our model. Our model is completed. We have tested our model also. Everything is ready. And now that is what I am asking. What is the differentiation you observed? What is the differentiation you observed between Y test versus Y predict and X new value versus Y1 new value in the model standpoint of view? Can someone give a try, or else should I?
Just one more minute.
If you talk with respect to the model, already model is completed and you're giving a new value to it.
Very good. Yeah. You are coming to the point.
To see what is going to happen. And
this is evaluation.
Which one?
The one, that new value, we are seeing how the new value versus the Y1. The second one is the evaluation, like how the model is performs with the new.
Venkat, see how the model is performing. You could have done in this step only, na? Because
yes. That is what the model is completed there.
Model is completed, and we are happy with our performance, like maybe RMSE, R square, or adjusted R square.
Or you can take it as a new train value. Train is completed.
Actually, training, testing, all the model evaluation,
activities
everything
are completed.
We it as model deployment after we if the model is successful, the next step is that what you are meaning to say? Like
that's all. See, one important thing is, if I am telling friends Y test versus Y prediction, that means everything is done on the standpoint of the model. But this is not the exact outcome. Na? Outcome is, see, the defense of this model, and as a developer, as a data scientist, you are happy with your model. That is perfectly all right. But in the client point of view, client, you are claiming that 92% of my 92% of accuracy is there related to my model. Okay, because you have enough evidence on that, because you have implemented your model and you have tested various measures, and you are showcasing all your RMSE, R square, right? Now the thing is, already if I'm using the word testing, it is related to Y test and as well as the Y pred. Now this particular thing, friends, after deploying your model or after giving your model to the client, now it is the client turn. Okay, it is the client turn, so as to expect, okay, new parameters, okay, by substituting the new parameter in the model, okay, by substituting the new parameter in the model, and he can make the predictions. That's all. He can, not the predictions actually, he can observe the results, direct results. One important point I can say, friends. Suppose we are having 2001 to 2020 book sales. 2020 book sales. Now we have implemented our model. Okay, like 75-25%, all these testing, all these things are done. Now if I am referencing 2021 2022, I want to get the values through the model, whatever the values. Can I say this as a testing or what? Can I?
No, it's the next step.
It is the next step, friends. See, that is what I'm trying to explain.
We call it as model deployment, or
this is not the model deployment, actual expectation of the value.
You say UAT testing in
Ah,
software engineering.
Where
the client comes and tests before production, go live.
Okay.
Before go live, we give our product to the client.
Okay.
And they'll test all the things, and once they say okay, then it will be going for the go live for the production.
See, one thing, friends, one more important thing is this bookstore is such a huge bookstore, friends. Assume that, and they should be ready for the demand. They should be ready for the demands and orders, and they are having this particular data with them. And as a company, we have provided the model and we have given everything for them. Okay, like if suppose 2001 to 2018, whatever the things we are having, and 2019-20, whatever the sales we are having, based on that particular thing. So just we have given the correlation. Okay, year sales, like that we are getting. Now client should be ready for the customer demands, because he is maintaining a bookstore and he don't know how many books he need to keep. Maybe assume that, friends, maybe that +2 or engineering kind of the records he need to purchase. Okay, he need to purchase from the other some kind of the other salespersons or whichever. He has to put some order. In that particular case, he should observe that in 2021 and 2022, what could be the demand of these records related to +2 and as well as the engineering students, so that he can be ready with all these kind of the books. Okay, your model is important to you, friends, but in the client point of view, model is not important. How your model is helping him in the real time. Hope you got the point now. See, the up to implementation of your model and you are getting 92% or 95% accuracy, that is your business. Once you deploy the model, he is not going to come back and check your training or testing or whatever the efficiency and what measures you have used, what algorithm you have used. No, client simply gives, okay, instead of 2020, he put 2021 and 2022, and he is getting the appropriate demand of the corresponding books or something. So your model is not only implementing the training data and as well as the testing data. Apart from that, expected values. Okay, always there is the observed value and as well as the expected value. From the observed values, whatever the values we have observed, we are going to generate that particular expected value. Accordingly, the persons can be ready. And even in COVID test also, friends, how they are telling, friends, how they are telling the third wave, fourth wave or nth wave, we don't know how many waves are there actually. So how they are telling, friends, based on the trends actually, they nicely come up with some kind of the graph, and based on this convention, okay, they say that, okay, by March 2022, definitely we are going to get these many cases. It is all depending on the existing data, and based on the observed data, just we are going to generate the expected values. That is how you can observe your understanding of this particular existing model in the client standpoint of view. Okay, now you refer this point, friends. Now one more important feature, you can enjoy this actually. In the earlier example, okay, this time this class I am using to walk through this example, and we are going to compare the existing method with the current method. What is the method we have used to pick up the feature, the X value from the data set, friends, in the earlier example? What is the method we have used? You should be in a position to immediately respond. What is the method? What is the process we have used to separate dependent and as well as the independent values?
We have used ILOC.
ILOC. Okay. So ILOC, you need to specify that whatever the index values I'm having, that I need to specify. Now you see, friends, just what I'm doing is I am just mentioning that just this particular column information. You need not remember what exactly the location or index value. Simply you can specify, okay, this column I want to put into this particular advertisement. And what is this X value, friend, by the way? This X is nothing but
Independent variable.
independent variable. So now my independent variable is TV marketing. Okay, that means our X is only containing the TV marketing. Okay, now you see the what is the way how to pick up the Y value, friends? That is a response variable. Just you need to mention the name of that particular column. Okay, just advertising and as well as the sales. Just we are going to get the outcome as Y. Okay, so this is how you can refer. And now up to this point, okay, this is the difference, friends. Actually, in case of the earlier data pre-processing example, there we have used the ILOC. Now we are using this particular name of the index. That is your wish, friends. If you ask me which is efficient, and definitely I can say ILOC is the efficiency in case of the memory and as well as the processing point of view. But whereas in case of the user standpoint, maybe the user is not having idea about, is not strong enough in the coding, then we can go with this kind of the convention. There is no objection, friends. Whichever, either way is perfectly all right. Okay, no doubt about that. Now, have you seen this particular point somewhere, friends? By chance, training test split.
Across validation, we have seen, when we have this underfit and overfit, like to reduce the overfit.
Exactly. Now, one more thing, friends. In the earlier example of the train test split, what we have done? Train test split belongs to train test split belongs to scalar. Under that scalar,
Pre-process.
pre-processing a train test split. Model selection. Friends, you should be very keen in this point. Okay. See, the point is at the moment you are saying your train test split is data pre-processing, he won't ask any next question, friend. Be careful about that, because it shows maybe the second example only we are talking.
Got
But you know, Venkat, those kind of statements we should not use. Okay, that is what. Just take a pause, think through, because there is a bit trick actually. If you are entering into the zone of the train test split, you would have completed all the data pre-processing. That is a thumb rule, friend. Just to remember like that. Again, I am repeating. If you are coming up to the train test split, if you are coming to the level of the train test split, you would have completed all the missing value imputation, encoding kind of things, scaling aspects, all these things. Then only once you are happy with your data set, once you have done all the curation of your data, okay, then only we are talking about the train test split. One more difference you can observe here. In our train test split of the earlier example, we have taken the thing of that model selection. From scalar model selection, import train test split. Now our Venkat is trying to say cross validation. Now you tell me, Venkat, what do you mean by cross validation? Which cross validation we have discussed in the session? Venkat got hurted, it seems.
No.
See, Venkat, you just simply heard, but I feel very shivered. Okay, if my in my group, okay, if some member is talking about train test split is a pre-processing, then I got blank completely. Okay, so 10 times or 20 times greater than your shivering I am having. Okay, right, now you tell me.
On cross validation, I'm still thinking whether what I've told is correct or not.
K-fold cross validation. You are right. You are right. K-fold cross validation. What is that?
It takes care of the overfitting.
Overfitting. Yeah. How? Yeah, your analogy is correct, Venkat. See, that's what I told. What exactly that point? Why we need to use and how? Yeah.
It simply by hearts, so it doesn't it doesn't learn from the data. So when we need to ensure that the training data contains all the
Very good.
aspects of the data.
So our model should explore all the possibilities of our data. All possible classes or all possible distribution should be explored by our model. Okay, na? That means in my data, I am having class 1, class 2, class 3 kind of the data. I need to equally bucket. Okay, I need to equally explore that particular data. If I am not saying this, it is just randomly splitting the data, friends. You know, so because my interest here is, as I'm TV marketing in US, TV marketing in UK, TV marketing in India, like that I may be having some kind of the country's data. So I need to train test split in such a way that all the US data, UK data, India data, I should fit in a proper arrangement. For that particular purpose, I am making use of this cross validation. Okay, so my k-fold cross validation helps me like in such a way that whatever the data I'm having, if I want to distribute my data equally likely, okay, in all the kind of the classes, and I want to give this particular data to my model in a proper way, then I can go with the cross validation. So sklearn dot cross validation and simply train test split, and now it is very clear. What is this x value? What is this x value, friends? Features. What is your y?
Label.
Label. What do you mean by train size? Earlier we have used the test size. Now what we are using? Train size.
70%.
70%. Yeah. What do you mean by random state here?
The random state is 100.
100. So just I can give any random number or I can give any arbitrary number because I'm only testing my simple linear regression. I'm not tagging any other algorithm. It is not the matter. Okay, there is no validity for that random state equal to 100. You can give any number. Okay. Now, so just we are typing all those things, type of the data, series kind of the data, shape. Now, especially friends, in this algorithm, we need to be take care about this particular shape because it is saying that your X training, Y training, X test and Y test are not having any number of columns information. Only it is showing the number of rows. Now you can perfectly see X train, Y train or how much, friends? Out of 200 records, we're having 140, 140. Your X test and Y test belongs to 60, 60. That means 70% of the data, okay, is spread over X train and as well as the Y train, and remaining 30% is spread over to the X test and as well as the Y test. Hope you got the point, friends. So here it's not simply if you are changing this particular thing, obviously it is going to affect in the number of records also. It is always better to have 80% or 70% as the train size. Accordingly, the appropriate training would be there, and finally the testing. Now, okay, the problem here is as we are working with only the rows, but I want to get the columns information also. Only while using the simple linear regression, you need to take care about the next axis, because in simple linear regression, how many independent variables we are having, friends? Only one. And in multiple linear regression, how many we are having? At least 2 or more. Okay, maybe, but at least 2 if I am having, then I can say that is a multilinear regression. In this particular case, we have to compensate this particular thing with the new axis. Okay, nothing else, friend. Just we are adding one more new axis so as to compensate this thing. Now you see here, just I am using 140 records with single column like that. Okay, so and one more thing you can observe here. I am interested in my X train and as well as the X test. Why? Can someone help me to understand that? What is the reason behind that, friends?
That is what we give to the model.
That's all. That is what we give to the model, nothing else. Because our Y test and Y train are just for the sake of comparison only. Okay, and definitely if you see X train and as well as the Y train we are giving, and in case of that particular X train, I need to compensate my number of records. Whereas if I am talking about the X test also, this particular X test is used to observe, okay, how these particular values are behaving in the Y prediction. So that is the reason behind just we are keeping track of this particular X train and as well as the X test orientation. Now we are entering into this genre, friends. Okay. Now so far, okay, we have seen the importing, loading of the data, and as well as observation of this particular info and as well as the describe, and thereafter now it is a time to get into the training and test split. Of course, that is also we have seen with the simple differentiation. The simple differentiation here is, in case of the earlier example, we have seen train test split in the genre of the model selection. But whereas in case of the current example, we have seen our train test split in the cross validation. Reason also we have seen. Now you spend some time here, friends. Just 2 minutes, that's all. Okay, so just you can observe at least which are all the names we are using in the implementation of our algorithm. Just you can observe in the earlier cases from sklearn dot pre-processing, from sklearn dot compose, from sklearn dot model selection, like that. Similarly, nothing changed, friend, no change, nothing. Okay, simply I am making use of my basic property of the sklearn. Within that I am having the construct called linear model, and my interest is I want to implement my linear regression. So just you can observe here, friends. I want to import my linear regression. Very simple. What is this LR, friends? Here earlier example also we have seen, whatever the class I am having, before going to use that particular class, I have to give the reference of that particular class. So now we are making use of the reference of this linear regression. Now just to observe here, friends, we are fitting a model. So just we are sending which are all the parameters we need to give to fit the model? X train and as well as the Y train. What do you mean by X train, friends? What do you mean by X train?
As,
My 70% of the
data.
independent independent variable. What do you mean by Y train?
70% of the
Dependent data.
or,
That's all. Na? So that means based on the 70% of the data, we are going to construct the model. Hope you got the point, friends. Hope you got the points. And hold on, these are very important. I'll talk in the next session. Now, coefficient calculation. Why we need to calculate the coefficient, friends? In the just now we have seen. That means after getting that TV, okay, after getting the sales value, now my interest is, if I am giving the new value of the TV, I should able to predict. Okay, I should able to predict my whatever the value I'm having. So if you are referencing this point, friends, actually if you are referencing this point, whatever the coefficient intercept value I'm having. So just if I'm talking about the Y value, Y equal to some kind of coefficient plus these kind of value, whatever the value I'm having. Okay, so just if you are referencing these kind of the data, whatever the data I'm having, I want to fit this particular model in such a way that by computing my intercept value and as well as the coefficient value. From where we are getting these values, friends? If you observe LR, what is your LR here? What is your LR here?
Linear regression class.
Linear regression model. Okay, na? This is the linear regression, and we are referencing this linear regression. And with the help of that regression, we have fit that particular model. Now, your LR is not simple, friends. Your entire model is revolving around this LR. Now, I am able to get the intercept and as well as the coefficient, whatever the intercept value I'm having, whatever the coefficient value I'm having, so that based on these particular values, I can able to give the values like TV value, TV marketing. If I'm giving some value, obviously based on these particular two values, these are all your coefficient and as well as the intercept values according to your model. See, from this model, the model could able to generate your intercept value and as well as the coefficient value. So that is the advantage of generating the model, friends. Okay, and finally, what is your prediction? What is the value we need to give for the predictions? X test, na, so that so as to generate, just to connect the dots, friends. Okay, if you are not understanding the code, it's perfectly all right. But the logic you should be able to follow. X test, Y prediction. Now, RMSE and as well as the R square values. Where do we get these things? Matrix, import mean squared error and as well as the R square. Now, these particular things can be observed between Y test and as well as the Y prediction. Hope you got the point, friends. Okay, now between Y test and similarly R square also. Now you see here whether this model is good or bad. You need to comment on this now. Our squared error is 7.97. What it means?
Error
So more
should-
value.
Error value. Error value means
Error value is more.
no.
should be
7% is difference now. Only
Oh,
7
okay,
cases.
okay.
Out of 100, 7.9 times we could not identify
That's good.
properly. Okay, there is some percentage. What do you mean by this thing? Around how much percentage we are having R square value? 60%. Friends, here starting from the 60, 70, that not
Not a
good,
good
but
way. It's okay.
not bad. It's
Not
not
also
bad.
okay.
Not okay, not bad. Not bad, I
okay.
guess. That means our TV marketing, okay, is at least I can say our model is predicting 60% of the values. That means our R square value is 60%. I can say that my accuracy is based on these kind of things. Okay, now you see, friends, here just you observe. First, we have given the data loading and then exploratory data analysis and then visualization process and simple linear regression stat behind that. And thereafter loading of the dependent and independent values, treating of the train test, and then implementation of linear regression, and then predictions and your model evaluation. See, friend, this is what how you can observe. Of course, in one session, definitely
Super.
I cannot complete the kind. Okay, only the thing is, if you are able to connect the dots, whatever the stats, whatever the concepts you have seen, simply you can. Tomorrow, if you observe, friends, in the class, definitely you enjoy because Suresh already got the essence so that he could able to
I
explore.
got
that.
the sense. Yes.
Yeah,
You got
yeah.
me correctly.
Okay, now, but whereas if you refer the tomorrow session, all other members who are in the call, definitely they can able to connect all these kind of the dots. Oh, this guy, because of this, these things, he has spent that much time in stats and probability and as well as measures and algorithmic explanation. Okay, because your code is nothing but the conversion of understanding into the reality, friend. That's it, nothing else. So if you are not okay with the understanding, okay, then we are unable to make up that. And you may ask me, what is this? This is nothing but the differentiation between y test and as well as the predicted value. How differentiation? This we'll see in the tomorrow session. Okay, that's all, guys. Yeah, thank you. Thank you.
when we see the visualization, I think we can make a good assembly. Like, do you remember when you are showing the visualization using
Seaburn, yeah.
Doing that had good density. When we try to get that kind of data, our values of this, when we do the measures, we'll have a good number saying that the model is like
definitely exactly perfect model. Yeah. Now, can someone help me, friends, to understand which are all the key takeaways of today's session? We started our discussion with
simple linear regression.
Regression. Okay, and we have seen the example of the TV marketing versus sales. Can someone help me? Which are all the template based activities we have seen? First is the import of the libraries.
Loading of data sets.
Very good. This flow must be there, friends. Loading the data set.
Separation of independent and dependent variables.
Very good. Separate dependent and independent data. Next one is
value.
We
do not have missing value in this.
Yeah. Then once this is over, then what is the thing?
Went for the split. Split using this
cross
validation. Very good. Of course, you can perform with the model selection, but there is a clarity now why you are using cross validation. Next is after test state split. What is the next point we have seen, friends?
Model. Linear.
Just we have seen the shape. Okay, and then model
Selection model. Model selection from
model selection.
Model import actually.
Model import, I can say, rather than import the model. Once this is over, friends, actually linear model. From the linear model, we have selected that linear regression. We have same name, whatever the name we are having for the algorithm for this class also is the same name. What next, friends?
We have supplied the parameters to the linear regression.
Like we have created the reference of linear regression. Okay, this is the reference we have created, and within this reference, what we have done, friends, fit the model. What are the parameters we have shared here in the model?
X-train and white.
Very good. X-train and white ray. This is
Then
one.
Y predict and Y test.
Y pred is equal to predict of X test. Okay. Now we got everything, friends. So what is the next thing? Measure.
We have to do measures.
Measures. Which measures we have used, friends?
RSME and R square.
Around 7% we are getting. R square around 60% we got. Not a bad model. Okay, so this is how you can connect the dots of our earlier learning with the current steps, friends. Nothing new. Okay, only the thing is just we need to observe which are all the aspects we need to go through while implementing the algorithm. That's it. Okay, in tomorrow's session, however, we are going through each and every step of that particular coding. And if time permits, definitely we'll see the multiple linear regression with changes. Okay, because here only I am considering TV marketing, and tomorrow, in case of the multiple linear regression, I can take newspaper ads, how it is influencing, and radio kind of the marketing, how it is influencing. All these things I can observe. And Venkat, what is your topic in tomorrow's session?
I have to do this, pre-processing techniques.
Pre-processing you are doing, or have you started working on that? Hope you.
I have to.
I have to. Then okay. Which one do you feel better? Okay, so that you can have a look on that. No problem. Whatever the aspects you feel.
I might be. I'll try to. Yeah. I thought of something else that might be helpful, or it puts overall perspective in picture.
Definitely, Venkat, whatever you feel. And moreover, if you can, again, you can talk about simple linear regression, multiple linear regression. Okay, because however, in tomorrow's session also we are going to talk about these things. Okay, if possible, you put the context of explaining the measures, or else explanation about the simple linear regression or multiple linear regression. You can use that point also, Venkat, because it helps the learners, so as a revision.
With an example, explaining the total will be the real good one. Actually, I didn't do that today.
Yeah.
Because you said it is 7 minutes for me. If I start with an example, it will go on.
Yeah, that is what.
This condition, Suresh, you are asking you want whatever we have discussed today, that example?
That or any you take one example and try to explain how the graph is proceeding with SLR and MLR. Point to point, how it is getting changed.
Maybe you can.
Y is equal to C plus MX.
Yeah, maybe you can talk
MX1, MX2, MX3.
the measures, and as well as how multiple linear regression is better than the simple linear regression in a simplest way, Venkat. Don't see always.
The way Suresh has presented, it's good.
Enough. Don't make unnecessary complex. It doesn't mean that if I am talking complex, then I am great. No, not like that. If I am talking simple, then only I can claim I am great, because I need to.
Also related.
That's it.
All the team as a revision.
That's all, guys. Thank you very much. Bye.